Welcome to this. We're going to talk about our new activity for the 10th of October, talking about using algebra tiles. Right. Um, so let's start off. There's a video we want you to watch. It's linked here. You can watch the linked version in the Google Classroom as well. So skip out of this and start with that, then come back to this. All right. Hey, you just watched that video. Here's a list of everything that gentleman ordered, or that gentleman ordered. Um, Look at this real quick and think about why was that a problem? Why was that so annoying? Really, is the best way to think about it. Talking to the class, they point out things like, "What would you order? Junior fries and a junior fry, two more junior fries, two more junior fries, that kind of stuff." Right? Hopefully, you're gonna look at this and you're gonna say, "Hey, why didn't they just put it all together into the things that are the same?" Right, and that's a good point. So, if you do this activity in class, you're going to have a small bag with three different types of tiles. You're going to have one big, large square tile that we are not going to use for this activity. You're going to have these long rectangle tiles. They're green on one side, red on the other. And you're going to have these small tiles that are yellow on one side, or tan on one side, and red on the other. Right? We're going to just use the green side of the rectangles, the long rectangles, and then we're going to use both the tannish yellow one for positive one and the red side for negative one. Alright, so let's take a look here. Let's write our expressions listed in these groups. So we're going to count those. So we have, get a color on here, we have one large, sorry, it's gray because we can't represent green on your worksheet, so this one's gray. But this one's supposed to be green, so we have one x value, right? Here's the x value for the green. And then we have three of the one values. 1, 2, 3. Alright. So for the next one, now we have 1, 2, 3 of the x values, the x's, and negative 1 of the rectangle, or the squares. Here we have 4 of the x's, and 1, 2, 3, 4, 5 positive ones. So we have plus 5. Now let's use this and represent the tiles. Once you represent them with physical tiles, you can draw. Alright, so I'm going to draw those. So I have, let's see here, we have 1, 2, and then we'll do blue for these. 1, 2, 3, 4. So there's 2x and plus 1. Do it again. We have 1, 2, minus 1. I'm going to color that one solid. Again, we have 1x. 1, 2, minus 4. 1, 2, 3. So we've just represented these. So now we have an idea of how to type this out. Makes sense. The next one. Use your tiles to represent the following scenarios, then figure out another way to write the number of tiles that you have. What if we have two groups of 2x plus c? Well, we can draw those. Here's our first one. 2x plus 3. 1, 2, 3. And then here's the next one. There's 1. Oh, boy, the screen does not like that. 2. We can call it this. Or we can write it, two groups of these, we can count them. Let's do 4 x's plus 1, 2, 3, 4, 5, 6 plus 6. Nice. Let's pick 2 two groups of those, looks like that, right? Let's do it again. Three groups of x plus 1, so x, x, minus 1, 1. We can rewrite that as 3x. That's 1 minus 2 minus 3 minus 3. Two groups of 4x minus 2. 1, 2, 3, 4. We can rename that. Rename that way 1, 2, 3, 4. Negative x minus 4 Alright. Alright. The next one. Right, now let's write an equation using distributive for each mod. So we're going to go backwards from what we just did. Remember, these long gray ones are really the long green ones. So we have 1, 2, 3, 4, 5, 6. We have three groups of 2x plus 1. 2x plus 1. So we call that three groups of 2x plus 1. Right? That's equal to 1, 2, 3, 4, 5, 6 plus 3. You're thinking at some point about how we go from this one to that one. Let's do it again. Now I have 6x minus 1, 2, 5. Each one of these is a negative 1, so minus 5. 6x minus 5. And here we have 2 of 6x minus 5. Over here we're going to have 12x minus 10. Right? Here we have 3x plus 2. 3x plus 2. Three groups of 3x plus 2. 9x plus 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so this is the way to write. We're saying there's three groups. So groups, right, inside of each group. That's what the groups are composed of. This is how many numbers are. You see, we can use multiplication to get there. Let's see. These tiles represent the expression. We write the expression without parentheses. So now we have three groups of x plus 1. So 1, 1, 1. And what can I say? Plus 1, 1, 1. And we know that means there's 3x plus 3. Four groups of 2x. Oh. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3. 1, 2. So we're going to rewrite that. We got 1, 2, 3, 4, 5, 6, 7, 8. 8x minus 12. Now we have 3x minus 1, 3x minus 1. Right, we're going to rewrite that as 6x minus 2. makes negative 2. Alright, so let's see what that means. Does 4 times the quantity 2x minus 5 equal 8x minus 5 or equal 8x minus 20? Well, 8x minus 20. Because 4 times 2 equals 8x. But 4 times negative 5 is going to be negative 20. What's better than 8x? That's 20. That's 20. Ooh. Problem set for these 17 through 20. Explain why the distributive property was not applied correctly. Alright, so here's what I mean. Look at this. We know that we're going to have 4 groups of 2x plus 1. That means we're going to have 8x plus 4. Once we have the plus 1, so that's wrong. 4 times 1 equals 4. 5 times 3x is 10x. 5 times negative 2, negative 10. Here we have 7 times 3 to make, 21x. 7 times 1 plus 7. Don't add. Multiply. Alright? 20. We have 3 times 2 is 6. Minus 18x equals, look at the x movement. X moved. Alright? Last question. Suppose one of the classmates as from class today, showing you to know what the distributive property means. Look over your work with activity and briefly describe the distributive property. This is your homework assignment for this one if you choose to do it. We want you to complete this question. Okay? Communicate this with the teacher. What does it mean?